Hello, I am Isaac Boldt, the team leader, presenting on behalf of my teammates Zach Peterson, Caleb Zaborney, and Hannah Stephans. We are Senior Design Team 1 from the Biomedical Engineering Department at Michigan Tech, and our project is titled Body Mounted Sensors Aircrew. Our sponsor for this project is the Systems Engineering Research Center under the United States Department of Defense, and our client is the United States Navy. The Navy is interested in developing a secure, that is, non-RF system to be worn by aircrew during their daily activities that can be used to establish a baseline for physiological parameters of the individual, as well as for comparison to data obtained in flight. This data could be used to aid in the prevention of in-flight mishaps. They also wish for this system to have a visualization module. The system may also have potential uses in other military applications in the future. In order to solve this problem and meet the needs of the Navy, our team decided to create a body-worn system consisting of wired sensors securely attached to an elastic strap. We were directed to monitor three physiological parameters: body temperature, respiration rate, and heart rate. Additionally, they requested incorporating a way of classifying activity intensity. After consulting the literature, we decided to use a thermistor for measuring body temperature, a strain gauge for monitoring respiration rate, a single lead heart rate monitor, and an accelerometer for gauging activity intensity. We also integrated each of the wired sensors into a printed circuit board, which was connected to an Arduino Mega and powered by a 9-volt battery. The collected data was saved onto an SD card in the form of a text file, allowing for quick and easy importing into MATLAB for subsequent analysis and visualization. The other major objective of this design includes the system having the ability to effectively visually display the collected data for analysis. Based on the strengths of our teammates, MATLAB was chosen as the coding language. Each data point is categorized as either low, moderate, or intense activity. This is done by comparing the instantaneous acceleration magnitude to thresholds established using the results of our testing. Next, all of the data points are plotted on a graph showing normal and abnormal values at activity threshold. For example, the expected heart rate values are higher for intense activity than for low activity. The stoplight system is shown by red, yellow, and green boxes added to the graphs. After each time point has been classified as either low, moderate, or intense, a statistical analysis is performed on each category, as well as a global statistical analysis of the entire dataset. 4 different buttons were incorporated into the UI to allow the user to switch between the data. Each of these buttons displays either the entire dataset, only low activity, only moderate activity, or only intense activity. Each button changes what is being plotted and the statistical analysis that is displayed. Our team tested the system through a series of tasks. Each of the tests were conducted for a total of 15 minutes. The tests include being at rest, walking at a light pace, and climbing stairs. We had 4 different test subjects complete these series of tests. In conclusion, the team was able to integrate all the sensors needed for establishing a physiological baseline into an Arduino code. The data was successfully stored on an SD card and it was imported into the MATLAB code the team had created. This MATLAB code and its easy-to-use UI allow the user to determine a baseline for the test subject. However, there are many modifications the team thought of that could substantially improve the system. Further testing with more varied and levels of activity would improve the activity threshold levels. The system could also improve its security through American-made sensors. Finally, exploring other options to obtain a higher sampling rate would be beneficial for data quality. The team would like to thank CERC and the Navy for giving us the opportunity to work on and learn from such an interesting project, Captain Shepard and Colonel Pernado for using their time and experience to help us improve, Lieutenant Commander Moore, Rachel Ryan, Mara Kilgore for contributing their expertise, and finally our project advisors, Dr. Kirkpatrick and Dr. Rao for their guidance throughout.